So, hi everyone. Now we are going to start the chapter electricity of class 10. There are some topics which we have already discussed, like what is current, what is charge, the Ohm's law, resistance. All these topics we have already discussed. Let's just take a very quick overview. The resistance, it is a property to oppose the electric current in the electric circuits, to oppose the current, to obstruct the electric current through the conductors or in the electric circuits. A resistor is a device which offers the property resistance. Resistor is a device, electrical component which offers the resistance, which opposes the current in the electric circuits, right? Its SI unit is ohm. From Ohm's law, we have the expression of resistance R is equals to V over I, potential difference per unit current. Next, factors. What are the different factors on which the resistance of a conductor depends? There are the four factors: length, area, temperature, and nature of the material. Resistance is directly proportional to the length of the conductor, and resistance is inversely proportional to the area of the cross section of the conductor. Resistance of the conductors increases with increase in temperature, and it depends on the nature of the materials. These are the four factors on which the resistance of a conductor depends. 90% chances are there that question is asked from this topic, factors affecting the resistance. Next, we have when we combine these two factors, the length and the area. What do we have when we combine these two factors? We got R is directly proportional to L over A. When we remove the proportionality sign, we have a constant, that is rho. The proportionality constant called the resistivity of the conductor. When we rearrange this equation, rho is equals to RA over L. Its SI unit is ohm meter. So how we can define the resistivity? It is a specific resistance. Specific resistance when the length of the conductor is 1 meter and its area of cross section is 1 meter square. यानी कि resistivity भी resistance ही है कब? When the length of the conductor is 1 meter and its area of cross section is 1 meter square, right? Some students may confused in the definition of the resistivity. And one most important point about the resistivity does not depend on the length and the area of cross section. It just only depends on temperature and nature of the materials. The question may be asked in the previous years. It already asked in the PYQs of CBSE board of class 10 that if we stretch the wire twice, then what is the new resistance and the resistivity? So what is the answer? How we can find when we stretch a wire? So we know resistance depends on the length. So how it vary according to the length? Very short formula is R dash is equals to n square of the original resistance. जितना original resistance है उसका n square. तो जिस भी फैक्टर से आप लेंथ में चेंज कर रहे हो, अगर आप उसको ट्वाइस कर रहे हो तो फैक्टर 2 हो जाएगा, n की वैल्यू 2 होगी. अगर आप उसको हाफ कर रहे हो तो n की वैल्यू हाफ हो जाएगी. So square of n, that means 4 times of the original resistance. इनके resistance आपका 4 times हो जाएगा original resistance के. And what about the resistivity? Resistivity does not depends on the length and the area, so it remains unaffected. It remains unchanged. Understood? How we can derive कि हमने अगर stretch किया length को तो volume remains constant, क्योंकि suppose if we have a rubber band, हमने rubber band को stretch किया तो आपने देखा होगा उसकी लेंथ इंक्रीज हो जाती है रबर बैंड को जब हम स्ट्रेच करते हैं, बट एरिया भी तो रिड्यूस हो जाता है ना, वो इस तरीके से पतला हो जाता है. तो जितने फैक्टर से लेंथ इंक्रीज हो रही है या लेंथ में चेंज हो रहा है उतने ही फैक्टर से एरिया रिड्यूस होता है. अगर आप लेंथ को ट्वाइस कर रहे हो तो एरिया हाफ हो जाएगा. अगर आप लेंथ को थ्राइस करोगे एरिया 1/3 हो जाएगा. अगर आप लेंथ को 4 टाइम्स स्ट्रेच करके इंक्रीज कर रहे हो तो एरिया 1/4 हो जाएगा. अंडरस्टूड? सो इसलिए ये भी ऊपर जाके उतना ही हो जाता है, तो स्क्वायर, इसलिए हम n स्क्वायर कहते हैं. ठीक है. सो दिस इज हाउ वी कैन फाइंड द ओरिजिनल रेजिस्टेंस. और अगर आपको ओरिजिनल रेजिस्टेंस 10 ओम दे रखा है तो यहाँ पे 10 की वैल्यू पुट कर देना. तो R डैश न्यू रेजिस्टेंस इज इक्वल्स टू n स्क्वायर ऑफ R, यानी कि द ओरिजिनल रेजिस्टेंस. सो मोस्ट प्रोबेबली यहां से क्वेश्चंस पूछे जाते हैं. So all these questions we have already discussed. ठीक है? Then we have a current of what we have given. We have given current. A current of 0.5 ampere is drawn by a filament of electric bulb for 10 minutes. Find the amount of electric charge in the circuit. जो भी हमें चीजें given होती हैं, the physical quantities that are given in the question, we have to firstly write them. So current we have given is 0.5 ampere. Then time, it's being 10 minutes. ठीक है? First and most important thing before solving the question or before solving the numerical, just convert all the physical quantities into their respective SI units. सबसे पहले उनको SI unit में convert करना बहुत जरूरी है. So 10 minutes, 1 minute is equals to 60 seconds. The SI unit of time is second. तो 10 minutes को second में convert कर दो. It's being 600 seconds. ठीक है? 1 minute is equals to 60. So 10 minutes में कितना होगा? It's being 600. And in 1 hour, 3600. ठीक है? Then we have to find the charge. The SI unit of current is ampere, the SI unit of time is a second, and the SI unit of charge is coulomb. So what is the relation between these three? सबसे पहले चीजों को लिख लिया गया. ठीक है? लिख लें जो भी फिजिकल क्वांटिटीज क्वेश्चन में गिवन है. उसके बाद जो पूछा गया है, put the question mark over it. उसके बाद इन सब में कौन सा रिलेशन बन सकता है, कौन सा फॉर्मूला यूज हो सकता है, वी हैव टू यूज दैट फॉर्मूला. तो करंट आई टी और क्यू से कौन सा फॉर्मूला होता है, आई इज इक्वल्स टू क्यूब ओवर टी, यानी कि करंट इज इक्वल्स टू रेट ऑफ फ्लो ऑफ चार्जेस क्यू ओवर टी. तो यहां से हमें क्यू फाइंड करना है, तो क्यू इज इक्वल्स टू आई टी, राइट. क्यू की वैल्यू यहां से क्या आएगी, आई टी. तो पुट द वैल्यू, करंट कितना गिवन है 0.5, टाइम कितना गिवन है 600. सो पुट द वैल्यू, सॉल्व इट. 1 0 कैंसिल विद 1, इट्स बीइंग 30 एंड दिस 1 0. ठीक है? सो इट्स 300 coulomb is the answer. ठीक है? Next we have calculate the number of electrons in 1 coulomb of charge. That means charge we have given is 1 coulomb. We have to find the number of electrons. That means n. So in this we use quantization of charge. What is the formula for quantization of charge? Q is equals to Ne. What does it mean? That charge is quantized. Charge is in the form of discrete numbers, countable numbers. So charge is the integral multiple of the base unit E. This is charge on electron or proton. What is the magnitude of it? 1.6 into 10 raised to the power minus 19 coulomb. So E, the smallest charge that exists on earth, is the charge of an electron, that is 1.6 into 10 raised to the power minus 19 coulomb. तो E की वैल्यू हमें पता है, हमें चार्ज गिवन है 1 कूलम, हमें n फाइंड करना है. तो रीअरेंज इट. n कैसे होगा, चार्ज पर यूनिट E. तो चार्ज हमारा है 1 कूलम, E की वैल्यू पुट कर देंगे 1.6 इंटू 10 रेज टू द पावर माइनस 19. सो दिस गोज अप, इसको डिवाइड होगे तो 0.625 इंटू 10 और 16, तो 0.625 into 10 raised to the power plus 19. This is the number of electrons in 1 coulomb of charge, right? Next we have, next question. How much work is done in moving a charge of 2 coulomb? We have given charge of 2 coulomb across 2 points having the potential difference. Potential difference delta V we have given is 12V. आप पोटेंशियल डिफरेंस को V से भी रिप्रेजेंट कर सकते हो या डेल्टा V से भी रिप्रेजेंट करते हो. डेल्टा मींस चेंज. ठीक है? सो पोटेंशियल डिफरेंस इज 12 वोल्ट. दिस इज चार्ज इज गिवन 2 कूलम. तो व्हाट इज द फॉर्मूला फॉर वर्क डन? अगर आप इसको V से भी रिप्रेजेंट करना चाहते हैं तो यू कैन रिप्रेजेंट इट विद V. सो व्हाट इज द फॉर्मूला फॉर वर्क डन? वर्क डन इज इक्वल्स टू पोटेंशियल डिफरेंस इनटू चार्ज, क्योंकि पोटेंशियल डिफरेंस क्या होता है, V इज इक्वल्स टू वर्क डन टू मूव अ यूनिट पॉजिटिव चार्ज. So from there work done is equals to potential difference into charge. ठीक है, so potential difference we have given 12, charge we have given 2, so work done is equals to 24. The SI unit of work done is joule, so we have 24 joule work done to move 2 कूलम ऑफ चार्ज. ठीक है, 2 कूलम ऑफ चार्ज को मूव करने के लिए अगर हमारे पोटेंशियल डिफरेंस 12 वोल्ट है तो हमें 24 जूल ऑफ वर्क डन करना पड़ेगा, राइट. सो दिस इज हाउ वी कैन फाइंड. Next we have next topic. So these are the topics related to the resistance or the work done or the questions based on the previous topics which we have already discussed. The next topic we have is combination of the resistors. ठीक है, combination of resistors in the circuit. Right? So in combinations we have two types of combinations, series and parallel. So resistors in series combination and resistors in parallel combination. So first combination we have is series combination. Series combination of resistors. So series combination of resistors. So what is series combination? When the resistors are connected end to end. ठीक है, when the resistors having resistances are connected end to end in the circuit, end to end in the circuit across a battery having potential difference V, having the potential difference V is known as series combination, is known as the series combination. ठीक है, end to end जब resistors having n number of resistances connected across a battery or potential difference, then this combination is known as the series combination. How? End to end, that means this is resistor 1 having resistance R1, this is second resistor having resistance R2, and this is third resistor having resistance R3. They are connected end to end across a battery and a key. ठीक है, what you have to remember in the series combination, the most important thing that you have to remember is the current flows from positive to negative. The current I goes, the same current goes through or across all the resistances, same current. So in series combination, what is the most important thing to remember? Current remains same, right? Current remains same across each resistor or resistance. Resistor are the electrical components which offer resistance. So same current flows through all the resistances or the resistors, right? Resistor or resistance. Understood? And what is different? Potential difference across each resistor or each resistance is different. So it have a V1 potential difference, it have a V2, and it have V3. So all have different potentials. Right? So current remains the same, but the potential is different. If we have to find the net potential, so V is equals to V1 plus V2 plus V3. This is the formula to find the net potential across the circuit. So from Ohm's law, what is the expression which we get from Ohm's law? R is equals to V over I. R is equals to V over I. Yeah, V upon I. From here we get the value of V. So V is equals to I R, or V is equals to, yeah, V1 is equals to, current remains same. So we can say it's I1, I2, I3 is equals to I. So it's IR1 and V2 is equals to IR2 and V3 is equals to IR3. When we put these values, V of V1, V2 and V3 in equation number 1. So put the values of V1, V2 and V3 in equation number 1. What do we get? It's IRS, the equivalent resistance of series combination, that is RS, is equals to IR1 plus IR2 plus IR3. Taking common I from these, it's being IRS is equals to IR1 plus R2 plus R3. I is cancel out with the I. What we have? RS is equals to R1 plus R2 plus R3. This is the formula to find the resistance, the equivalent resistance in series combination. Okay? That means we can add individual resistances to find the equivalent resistance of series combination, and it has the maximum value. Okay? Instead of series combination, it may be asked to find the maximum resistance. तो maximum resistance कौन से combination में होता है? Series combination में. और parallel combination में we have minimum equivalent resistance. So this is RS is equals to R1 plus R2 plus R3. Here we get the maximum value because all the individual resistors are get added. ठीक है? यहाँ पे resistance add हो जाता है. Then we get the maximum value of equivalent resistance. So this is the series combination. But what is the most important thing about the series combination? Current remains same across each resistance and potential is different. Next we have parallel combination of resistors. So second we have the parallel combination. Parallel combination of resistors or the resistances. So what is a parallel combination? If they are connected one to one, that means like this. If you want, you can add ammeter in series or voltmeter in parallel combination. This is a resistor having resistance R1, this is R2 and this is R3 connected with the battery, okay, and a key. So when the resistors are connected one to one, okay, one to one with the battery, then this combination is known as the parallel combination. One to one, that means positive, one end of all the resistors are connected with the positive terminal and the another end of all the resistors are connected with the another terminal of the battery. Then this combination is known as parallel combination. What you have to remember about the parallel combination? Here potential difference remains same across each resistor. यहाँ पे V same रहेगा, but the current देखो, जो भी यहाँ से current आ रहा था I, that divides in this arm, then in this arm, then in this arm. So current divides, current is different across each resistance in the parallel combination and potential difference remains same. So here the potential difference remains the same, यानी कि V remains the same across each resistor or resistance, and current, that means I is different across each resistor or the resistance, right? So in this we have net current. We have to find the net current of the circuit. So net current I is equals to I1 plus I2 plus I3. Put this as equation number 1. Then from Ohm's law, it's R is equals to V over I, or if we have to find the value of I, so I is equals to V over R, right? If we find the equivalent resistance of the parallel combination, then I is equals to V over RP, or I1 is equals to, potential difference remains same, so V over R1, I2 is equals to V over R2, and I3 is equals to V over R3. Put these values in equation number 1. So put the above values in equation number 1. So what we got? V over RP is equals to V over R1, V over R2 plus V over R3. Taking V common from this, so V over RP is equals to V, it's being 1 over R1 plus 1 over R2 plus 1 over R3. So V is cancelled out with the V. So what we have? 1 upon RP is equals to 1 over R1 plus 1 over R2 plus 1 over R3. This is the equivalent resistance of the parallel combination. ठीक है? This is the resistance of parallel combination. Parallel combination, right? And this is the minimum, it has the minimum value, ठीक है? And R equivalent of parallel combination has the least value than the individual रेजिस्टेंसेस, यानी कि जो हमारे पास R1, R2, R3 की वैल्यूज हैं उनसे भी बहुत कम वैल्यू आएगी. बट वन मोस्ट कॉमन मिस्टेक द स्टूडेंट्स डू व्हाइल सॉल्विंग द पैरेलल कॉम्बिनेशन इज दैट they forgot to reciprocal it. That means from here we get 1 upon Rp, but we have to find the Rp. So if we have, suppose if we have the 3 registers, ठीक है, if we have the 3 registers, suppose connected with a battery and a key. Suppose if we have, this is 2 ohm resistance, it is 3 ohm and it is 5 ohm connected with the 12 volt of battery. So find current in the circuit. It is asked in the question. So first of all, we have to find the equivalent resistance of the circuit. So it is parallel combination. So it is parallel combination. So what is the formula to find the parallel combination? Equivalent resistance 1 upon Rp is equals to 1 upon R1, 1 upon R2 plus 1 upon R3. So 1 upon Rp is equals to 1 over 2 plus 1 over 3 plus 1 over 5. When we find its LCM, when we solve it, its Rp is equals to, it's being 30. So here we have 15 plus 10 plus 6. So 1 upon Rp is equals to, it's being 25 or it's being 31 over 30. So students left it. This is the equivalent resistance of parallel combination. But this is 1 upon Rp. You have to inverse it. Inverse this value to get its the value of equivalent resistance, that means Rp. So it's being 30 over 31 ohm is the value of Rp. In the parallel combination, we know each resistor has different value of current. Current is different. So first of all, we have to find the current across it. How we can find? This is Rp. This is 12 volt battery. So we have to find the current over here. Okay. So current across each resistor. We can find the current by the equivalent resistance, or we can find the individual current and then add the final values. You have this resistance and this V. So from Ohm's law, you can find R is equals to V over I. You have to find the current. So current is equals to V over R. So 12 over 2, it's being 6 ampere current through it. And from here, 4 ampere. And from here, it's 12 over 5. And approximate 2, more than 2 point something. So this is the final current. You can add all these values of current and find the final or the total current. Or second method, you have this equivalent resistance R, you have this, you can divide them to find the current. That means current is equals to V over R. So V is 12 over R. R we have 1 upon R. So it means 31 over 30. That means 30 here and 31 here. We can also find the value of current from here. So these are two methods to find the current. Individual currents and then add them to get the total current, or second method to find the equivalent resistance of the circuit and then find the current. But don't forget to reciprocal the equivalent resistance of the parallel combination, that is Rp. Next question we have, if this is given, now find resistance of the circuit. Now what we have to do, current goes, then it divides, that means it is a parallel combination. Then we have to firstly find the parallel combination of this. So what is a parallel combination? You can put the values. It is, suppose it is R1, it is R2, it is R3, it is R4. So R2 and R3 are in parallel combination. ठीक है, parallel combination, that means 1 over Rp is equals to 1 over 10 plus 1 over 10. ठीक है, LCM is 10. We have 2, that means 1 over 5. That means Rp is equals to 5 ohm we have. ठीक है, so the equivalent resistance of these two is 5 ohm. ठीक है, you can redraw the diagram again. How? Like this, 5 ohm na, so it is 5 ohm. ठीक है, now the current goes same, that means same current goes through these, so that means these, that means R1, it is R equivalent, and this R4 are in series combination. Okay, so R1 R equivalent and R4 now are in the series combination, right? Are in the series combination. So now equivalent resistance कितना होगा? Final one, it's being 2, it's 5 and 3. So 2 plus 5 plus 3. That means 10 ohm equivalent resistance we have in the circuit, right? So this is how we can find the equivalent resistance of the combinations, different combinations, that is series and the parallel combinations. ठीक है, but you have to remember कि अगर same current जा रहा है तो that is series combination, if the current divides that is the parallel combination. This you have to remember in these combinations. I'm giving you a few questions, you have to solve. ठीक है, this is first question. Second question is it is 12 volts suppose. ठीक है, $20 power supply. Third and last question you have is find the equivalent resistance of the circuit. Find the equivalent resistance of the circuit. So you can solve these questions. ठीक है, it is suppose 6 volt battery. So these are the 3 questions to solve as an assignment. So here we end today's lecture over.